The Fireye NXM2G control. If you're wondering what it is and how it can reduce your energy costs by between 10 to 25%, then let us explain. Much like a cup of coffee or a plate of hot food, when your boiler reaches its required temperature, it naturally loses heat over time. Now, it wouldn't make sense to heat up your food or drink when you don't want to eat or drink it, but yet this is what's happening to your boiler. It's heating up when you don't actually have a need for it. The NXM2G can stop this from happening, which in turn will save you money, energy, and reduces your carbon footprint. So why is the NXM2G required, you may ask? First of all, your boiler fires up heating the water inside. This hot water then flows out of the boiler and is pumped around the building. Finally, the water returns back to the boiler to be reheated, and your building begins to heat up. Most commercial properties will have a number of boilers working together to meet the demands of the building's size. At the beginning of the day, when the building is cold, the boilers fire to warm the property. Slowly, the building starts to heat up, but the boilers continue to fire until the building itself reaches its required temperature. Once the building's desired temperature has been met, the boilers will stop firing. The demand for heat has been met and they start to cool. As the boilers start to cool, they can fire again to keep hot, even though there isn't a need for heat in the building. This is what's known as dry or standby cycling. So how does the NXM2G work? The control works by detecting when it's necessary for the boiler to stop and when to go. By taking measurements every second, the control can see if there's a real demand for heat or if the boiler is dry or standby cycling. The NXM2G does this by measuring the boiler's temperature as the water flows out of the boiler and as it returns. As the boiler reaches its required temperature, the control takes a snapshot reading of the flow and return temperatures. From these readings, the control automatically applies a 14.5 degree deadband on the flow and a 5.5 degree Fahrenheit deadband on the return. Once the building has reached the desired temperature and the initial snapshot of the flow and return has been taken, the NXM2G then takes these readings every second and analyzes this data every 10 seconds. If the boiler's temperature gradually decreases in the flow and return and they remain within the deadbands, the control recognizes this as natural heat loss and not a real demand. It won't allow the boiler to fire unless either the flow drops 14.5 degrees or the return drops 5.5 degrees below the initial snapshot reading. The maximum period that the NXM2G can prevent the boiler firing is 15 minutes. If the boiler has no real demand, the control stops the boiler from refiring as normal. However, if there is a sharp decrease in either the boiler's flow or return, the control realizes that there's a real demand and allows the boiler to fire. The control identifies whether there is a need for heat or if the boiler is merely standby cycling. Once the boiler does fire up, the process starts again and a new snapshot is taken to measure the flow and return for the NXM2G to base its actions on. This means the control reduces the amount of times your boiler fires in a day, as it stops them from wasted, dry, or standby cycling. Perhaps you have already invested in a BMS, weather compensation system, or sequencing system. Surely that does what the NXM2G does? Well, BMS systems typically cannot identify dry or standby cycling, where the NXM2G can. How? Well, BMS systems, weather compensation systems, and sequencing systems typically use control strategies, which take measurements and control of all the boilers combined, but don't typically measure and control each individual boiler. Essentially, they macro-manage the boilers. You could think of these systems as a teacher sitting in front of a class of 30 or more students. The teacher knows that as a group, the class is on track. However, within the class, some students could be struggling without the teacher knowing exactly why. Imagine the NXM2G as the classroom assistant, sitting next to every student and working alongside the teacher, giving detailed information on each individual student's performance. Unlike other systems, the control micromanages the boilers, monitoring each individual boiler rather than the performance of all the boilers as a whole. That's how it identifies and prevents dry or standby cycling. What you might not realize is that BMS systems and the NXM2G work exceptionally well side by side. In fact, many users install NXM2Gs alongside their existing BMS systems. And where an NXM2G is in place, users typically experience energy cost reductions between 10 to 25% across their organization. The typical payback periods can also be very attractive.